Hi guys, my name is Mayank Sharma and the following video is me solving the first question for the end-term assessment of Introduction to Maths 2, that is subject code MAT104. So yeah, let's go ahead and solve the problem. So as it is mentioned in the question that YT represents the amount of fresh air that is present in the room at any moment t, implies that dy by dt would represent the rate of change of amount of fresh air with respect to time. So one of the basic aspects to solve these kind of questions is to form an equation based on the statements provided. So in this case we would get a differential equation, and let's see how it goes. As I said earlier, what dy by dt represents, and let's comprehend things based on the statements provided. First statement says that 600 cubic feet of fresh air flows into the room every minute. So this implies that the rate of inflow, that was 600, and since it is added into the room, this implied it is going to be positive. Another statement suggests that that 600 cubic feet of the air present, the mixture of air present, fresh air and the air that was already present in the room, exits the room. So what we need to calculate is the amount of fresh air that goes out of the room. For that would be like 600, that is the amount of air that is getting out of the room, by 20,000, since it is the amount of air present in the room, times y, that is the amount of fresh air uh, that is present in the room at any particular moment t. This intuition is pretty similar to that of percentage, as it is called this is the total amount of air, the total amount of fresh air that is present in the room at any moment, and this is the ratio that is of the amount of air exiting the amount of air already present. And since the so let's put it here, that would be 600 by 20,000 times y, and since it is exiting the room, that means there would be a negative sign. Let's rewrite it with using simpler notations. Be 600 minus 0.03, that would be y dash plus 0.03 y equals 600. This equation is a non-homogeneous linear ODE, that is ordinary differential equation. Now, those equations are usually of the form y dash plus p of x of times y equals rx. Here we have equation with y and t, so x would be, instead of x we would have t. So comparing this to the equation right here that I'm stating in the graph, it would be, we get the fact that pt here is equal to 0.03 and rt here is 600. So the method to solve these kind of questions is using the general solution of these kind of equation is yt, that would be yt equals e raised to power minus h c plus integral of r e raised to power h with respect to t. That's it. And here h would be the integral of p with respect to t. So yeah, let's go ahead and solve this. First thing first, let's calculate the value. Let's evaluate h. That would be p dt integral. P, as we know, is 0.03. dt integral implies h would be 0.03 t. Keep in mind and set aside for reference. Let's grab another workspace or sheet, we can see. As we got that h would be equal to 0.03 t implies our yt would be e raised to power, instead of h, what we're going to do is write 0.03 t minus 0.03 t times c is an arbitrary constant here, plus integral of r as we got in our equation would be 600. So 600 e raised to power 0.03 t with respect to t, and let's evaluate this integral. What we get is 0 minus 0.03 t c plus 600 upon 0.03 e raised to power 0.03 t, and yes, that's it. C, we need not to write c, I've already written for this particular purpose only. So what we get, the general solution for y, it would be ce raised to power minus 0.03 t plus this would be 20,000, and they will cancel each other out. So yeah, this is what we get. This is the general solution for the problem given. Next thing, the given problem is also an IVP, that is initial value problem, and the initial value, the statement for initial value given is that at t equals 0, the value of y is 0. So as simple as that, let's put t equals 0. In this equation, what we get is c plus 20,000 equals 0, implies c is equal to 20,000. So the absolute solution, the exact solution, if you can say, would be y t equals, let's take 20,000 as common, 1 minus e raised to power minus 0.03 t. This equation right here represents the amount of pressure present at any moment t. Now, and the question suggests that we need to find the time t at which the amount of pressure in the room consists of the 90%. The 90% of the total air in the room would be fresh air. This implies that yt is supposed to be 90% of the total amount of of air present in the room at any moment. So if we consider the fact that the inflow and outflow flow are constant throughout, like the rate should not alter, then we get 600 cubic feet enters, 600 cubic feet gets out. 20,000 was the initial 20,000 cubic feet was the initial volume of the air present, implies 20,000 cubic feet is always present in the room. Out of those, the 90% of the air is fresh air. So this is what we get. Let's put this value right here. We get 20,000. 1 minus e raised to power minus 0.03t, 0.9 times 20,000 implies 1 minus e raised to power minus 0.03t equals 0.9, and e raised to power minus 0.03t would be 0.1. E raised to the power 0.03t equals 10. No. Yeah, that'll be 10. And this would be, t would be equal to natural log of 10 by 0.03, and evaluating using a calculator, we get t as, you can say, approximately equal to 77 minutes. So yeah, this is the solution.